This video will demonstrate how to write Lewis structures, and I have 6 examples here of increasing complexity. Feel free to watch as little or as much of this video as you would like to support the lab on Lewis structures. So let's start with the first molecule. The first molecule is just F2. It's very simple. The first step in determining any Lewis structure is to figure out how many valence electrons you have. And to do that, you have to refer to a periodic table. So if we look at a periodic table, what you see is that you have anything in this first column will have 1 valence electron. Anything in the second column has 2 valence electrons. Then ignore all of this. This column has 3 valence electrons, 4, 5, 6, 7, and finally 8 valence electrons. So we have F2, so we look at the periodic table. Here it is in column 7A, and so it will have 7 valence electrons. Each fluorine has 7 valence electrons. So we're going to do our valence electron count, and what we do is we just say, okay, each fluorine has 7, and there are 2 of them to give us a total of 14 valence electrons. And so now what we want to do is we just want to draw the 2 fluorine atoms next to each other. And it's a very simple molecule. There's really only one way to connect them together. When we draw a bond, and that bond represents the sharing of 2 electrons. So then what we do is we're just going to add in our valence electrons, and we're just going to fill them in so that each atom will have an octet of electrons. So now let's look at our molecule, and we see that fluorine here this first fluorine has 8 valence electrons around it. See, 2, 4, 6, 8. This fluorine also has 8 valence electrons. And now we need to count up the total valence electrons in the molecule that we created to see if it matches how many we started with. So if we count up the total, it's 2, 4, 6, 8, 10, 12, 14. So we have 14 valence electrons in this molecule, which agrees with what we started with. So this is a proper Lewis structure. So let's go on to our next example, PCl3. So with PCl3, again, go back to the periodic table, and we find phosphorus. It's here. It has 5 valence electrons. Each chlorine has 7 valence electrons. So our valence electron count for the whole molecule, 5 plus 7 times 3 equals 26 valence electrons. So now oftentimes your first atom will be your central atom. And you also would follow the rule that the least electronegative atom is also your central atom. So let's draw phosphorus in the middle, put the chlorines around it, connect everything together with just single bonds at this point, fill in valence electrons to give each atom an octet of electrons, 8 electrons. And now we do a valence electron count. So we see that each chlorine has 8 electrons around it. The phosphorus has 2, 4, 6, 8 electrons around it. So everybody has satisfied the octet rule. And the total count is 8 plus 8 is 16, plus 8 is 24, plus 2 more is 26 valence electrons in total. So this molecule has 26 valence electrons, which matches what we started with. So this is a valid Lewis structure. So next example, CH5N. So here, if you look at this, if you looked at the carbon and tried to say, oh, let's make that our central atom, you can see that that's not necessarily going to work, because we would have 6 things that we'd be trying to attach to carbon, and carbon can't have any more than 4 bonds. And a very good rule to remember when drawing Lewis structures is that when you have a carbon, in general, you want to create 4 bonds to it. Carbon almost always makes 4 bonds. So let's start, of course, with our valence electron count. Look at the periodic table really quick. And carbon has 4 valence electrons. Each nitrogen is going to come with 5, and each hydrogen comes with 1. So let's go back down. And so we'll do this valence electron count. 4 plus 1 times 5 plus another 5. That gives us 14 valence electrons. And as we said earlier, we can't necessarily make carbon our central atom. So put the carbon and the nitrogen down and connect them. And then hydrogens are one of those exceptions to the octet in that they can only make 1 bond. So hydrogens generally sit on the outside. So we add in our hydrogens. And then the last thing we want to do is add in valence electrons for anything that doesn't have an octet that needs an octet. So you can see carbon already has its octet, and nitrogen only has 6 electrons around it. So let's add the valence electrons onto nitrogen. And now what you see is that carbon has its 8 electrons, nitrogen has its 8 electrons, and each hydrogen has 2 electrons. So the individual atoms are satisfied. And if we do a total electron count, we see we have 2, 4, 6, 8, 10, 12, 14 valence electrons. So we have 14 valence electrons in our final structure, which is an agreement with what we started with. So this is a valid Lewis structure. So now we'll go into something that involves more than just single bonds. Oxygen. So oxygen, back to the periodic table, we see oxygen right here with its 6 valence electrons. So valence electron count is always the first thing. And we have 6 times 2, so we have a total of 12 valence electrons. And this looks like a simple molecule. You just have 2 O atoms. We connect them together with a single bond to start, and then we fill in our valence electrons. And so in order to give each oxygen 8 electrons, we'd have to put 6 valence electrons around each oxygen. Now what you're going to see is that the oxygens are each happy because they each have 8 electrons. However, if we do our total valence electron count, we see we have 2, 4, 6, 8, 10, 12, 14. So we used 14 valence electrons to make this molecule. The problem is we don't have 14 valence electrons to work with. We only had 12 valence electrons. So what we're going to need to do is create additional bonds. What you want to do is you just want to eliminate the valence electrons that we didn't have to begin with. We didn't have 14, we only have 12. And then this pair we're going to share in a new bond. So we have a double bond. So if we redraw this molecule just to clean it up, you can see that we'd have an oxygen double bonded to another oxygen. And then we add the valence electrons in, and then we do our valence electron count, and we get 2, 4, 6, 8, 10, 12 valence electrons, and each oxygen has 2, 4, 6, 8 electrons in its outer shell. So since this molecule has 12 valence electrons, and we started with 12 valence electrons, this is a valid Lewis structure. So let's go on to this next one. So if we go to N2, again, as always, look at the periodic table. You can see nitrogen has 5 valence electrons. So we'll go back, do our valence electron count. It's 5 times 2. So we have 10 valence electrons. So just like with the oxygen molecule, there's not too many ways to bond this. We would create a single bond initially, add valence electrons to give each atom an octet, and you will see that we used 2, 4, 6, 8, 10, 12, 14 valence electrons to make this molecule. So we have 14 that we needed to make the molecule. So the rule is, for every 2 extra valence electrons that you used, you need to create 1 extra bond. So we used 4 extra electrons in this molecule, in this initial molecule, so we're going to have to create 2 extra bonds. So the way you would do that is, let's just get rid of, these. We don't have 14 valence electrons to start with. We only had 12, so I'm just going to cross out the ones that we don't have right away. And then these valence electrons and these valence electrons are going to get shared in additional bonds. So we create a triple bond. And if I redraw this molecule to make it a little bit neater, put in our valence electrons, we'll do our count. So this nitrogen now has 2, 4, 6, 8 electrons around it. Same with this nitrogen, and the total count is 2, 4, 6, 8, 10. So we have 10 valence electrons in this molecule, which is what we started with. So this is our valid Lewis structure. So one last example, HCOO minus. So valence electron count, let's go back to the table. Hydrogen has 1 valence electron, carbon has 4, each oxygen has 6. So we'll do 1 plus 4 plus 6 plus 6 plus 1. This minus right here means that there's 1 extra electron on this molecule. So the total for that is 16 valence electrons. No, 18. We have 18 valence electrons that we have to work with. And let's create our molecule. So carbon oftentimes is going to be your central atom. Carbon, remember, always likes to make 4 bonds. So therefore, you usually want to put your carbons down and try to attach everything to your carbon. So we have 3 things to attach to the carbon. The hydrogen can only make 1 bond. So that's simple. That's the only thing it can do. Now, the oxygens can each create, you can have 1 bond to each oxygen, but then you have to make a choice. And we know we want to make 4 bonds to carbon, so let's just choose to draw an extra bond to this oxygen, to the first one. We could have chosen to draw it to the second one, and I'll show you a resonance structure in a second. Now we have carbon. Carbon has the 4 bonds, so let's go and put our valence electrons where we need them. So carbon already has 8 electrons, hydrogen has its 2. This oxygen is going to need 2 more valence electrons to create an octet. This oxygen is going to need 6 extra electrons to make its octet. And so let's do our valence electron count. And you see we have 2, 4, 6, 8, 10, 12, 14, 16, 18. We have 18 total valence electrons. And that is the same as what we started with. So this is a proper Lewis structure. And one last thing you should do to finish off a molecule that has a charge is you put brackets around it and you write the charge on the outside. So minus just means it's -1. Now this molecule is actually one that has resonance. And what that means is we arbitrarily chose to put the double bond here. But we could have chosen to put the double bond here. And in reality, it's not here, it's not here. These electrons are shared equally between these two oxygens. So to denote that, you draw a resonance structure. And when you draw a resonance structure, you draw it in the exact same orientation. You just change the location of the double bond. So now the 6 valence electrons would go on the top oxygen, the 2 valence electrons would go on the bottom oxygen, and you still put your brackets with your minus sign, and you put this arrow, double-headed arrow, to show that these are resonance structures. So I hope this helps you in your Lewis Structure Lab.